Hi everybody. This video is going to be focused on trigonometric proofs. So we're really focusing in on the trigonometric identity sheet that we learned about in the last video, why trigonometric identities are important when we're trying to simplify and solve these types of trig equations. Okay, so proofs, they're a little different from equations because there's not like an equal sign on each side, but what we're really doing is we have this expression on the left, right? 1 plus secant theta times secant theta minus 1. And if we're trying to prove these two trigonometric expressions, we're going to try and prove that they're equal. Okay, so anytime you're doing proofs, you're trying to prove that the left side equals the right side. So unless you're some sort of math genius, it's not, you can't really determine that this left side here, right? Two brackets multiplying together is going to be equal to like the quotient of two products. It's just the way it's written, it's kind of confusing and you can't really do it in your head. So what we're going to do is we're going to use our knowledge of algebra and trigonometric identities to try and simplify both sides into something that is more recognizable. Okay, so when we're dealing with proofs, we want to focus on one side at a time because if you're working on two sides simultaneously, it just becomes a bit of a mess and you kind of lose track of what you're trying to do. Okay, so let's just look at the left first, right? So we have two brackets with two terms in each bracket multiplying together. You might remember this from factoring quadratics. To expand this out, we just multiply everything in each bracket into everything in the other bracket. So the 1, right, in the first bracket, we're going to multiply that into the secant theta. So 1 times secant theta is going to be just secant theta. Okay, and this 1, it's not quite done. Right, we still have to multiply it into that negative 1. So this is going to be minus secant theta. Or not minus secant theta, minus 1. I'm getting ahead of myself here. So we have secant theta minus 1. So in terms of this 1 over here, it's done multiplying into the other bracket. Now we got to move on to the secant theta. So secant theta times secant theta, that's going to be positive secant squared theta. Right? And last thing with the secant theta, we're going to multiply that into the negative 1 there. So secant theta times negative 1, that's minus secant theta. And you might notice that we have a secant theta here, except they're subtracting. So if we have a positive secant theta, taking away, we're subtracting secant theta, these two things are going to be gone, and all we're left with is secant squared theta minus 1. Okay, secant squared theta minus 1. Okay, so we expanded out the brackets, we simplified by combining like terms, and we got this expression right here, secant squared theta minus 1. And once we do that, there's not a ton we can do with this thing right here. So anytime that happens, once you expand it and think you're done simplifying, you're going to check your trigonometric identity sheet. So once you do that, you're going to notice that secant squared theta minus 1, that's equivalent to tan squared theta. Okay, that's equivalent to tan squared theta. So we started with these two brackets multiplying each other on the top, and we got it down to something that's literally just one term. It's tan squared theta. Okay, so I'm pretty sure that we're done with the left side here. Okay, so anytime you think that you're done simplifying on the left, we're going to move on to the right side here. Okay, so on the right side, we have sine theta times secant theta over cos theta cosecant theta. Okay, so for these types of questions, what I always like to do first is get secant and cosecant in terms of sine and cosine. So secant is really just 1 over cosine, right? It's the reciprocal of cosine. And we have cosecant, or cosine times cosecant. So similar to secant being 1 over cosine, cosecant is just 1 over sine. Okay, so if we have sine theta times 1 over cosine, the sine is just going to multiply into that 1 there. Okay, so we're going to have sine over cosine, and we're going to divide that by, remember this cosine multiplies into that 1 there, we're going to be dividing by cos theta over sine theta. Okay, and you might recall when we have a fraction on the top and a fraction on the bottom, right, and we're taking the quotient of those two fractions, anytime we're dividing by another fraction, right, we can bring this entire fraction out and multiply it by taking the reciprocal, by flipping the top and bottom of the fraction on the bottom there. Okay, so instead of saying sine theta over cos theta divided by cos theta over sine theta, we can bring out the cos theta over sine theta and say that's the same as, right, we're multiplying sine theta over cos theta. Okay, so instead of dividing by the reciprocal of this, we're multiplying by just sine theta over cos theta. Okay, so now that we have the fraction kind of rewritten like this as a product instead of a quotient, let's just multiply the tops and multiply the bottoms, because that's how we multiply fractions, right? So sine theta times sine theta, that's going to give us sine squared theta. And cos theta times cos theta, it's going to give us cos squared theta. Well, anytime we have sine squared theta, what that really means is we're taking the quantity sine theta and we're squaring it. And we're really taking cos theta and squaring that. Okay, and we can rewrite this as just sine theta over cos theta. And that's all being squared because this squared applies into both the top and the bottom for fractions. Well, what is sine theta over cos theta? Well, that's just tan theta squared. And you can see the connection, right? Because on the left side we had tan squared theta, and tan theta squared is the exact same thing, right? It's just a different type of notation. So that's the same as just tan squared theta. So the left side equals the right side, and we've effectively proven these two trigonometric identities to be equal. Okay, so let's move on to another example here. We have sine x plus tan x divided by cotangent x plus cosecant x. We're trying to prove, and the way we denote that is an equal sign with a question mark on top, but you don't see that a lot. But if you do, that's just kind of what it means. We're trying to prove that it equals sine x tan x. Okay, so I always like to take expressions like the ones on the right that are pretty simple and just simplify them even more. So like I said in the example above, whenever you see tan x or cosecant x, secant x, always try and get it in terms of sine and cosine. Okay, so sine x, that's already in terms of sine or cosine. And tan x, right, that's just going to be sine x over cos x. And sine x is going to multiply into the top there, right, into the sine x. So we're going to have sine squared x over cosine x. So there's not a ton more simplification we can do on the right side. We might be able to call this sine squared x maybe 1 minus cosine squared x to use another identity, but we're not sure what we're going to have to do with that. So we're going to leave that as it is, okay, and we're going to move on to the left side. All right, so let's kind of simplify this fraction here. Let's focus on the top here, the numerator first. That's what I always like to do. So we have sine x, and instead of writing tan x right off the bat, I'm going to get that in terms of sine and cosine, like we just did. So this is sine x over cos x, all being divided by this cotangent x. Cotangent x is just the reciprocal of tangent, which is going to be cos x over sine x, right? And we're going to be adding cosecant x. So cosecant x is 1 over sine x. All right, so whenever we have two fractions adding or subtracting together, you might remember that we need a common denominator. Okay, so right now we have sine x on the top, and that's the same as sine x over 1, right? And on the thing we're adding to that is sine x over cos x. So notice how these two denominators aren't the same. So the way they're written right now, we can't add these together. All right, we can't add these together. So what we're going to have to do is find the lowest common denominator and make that the denominator of both fractions. So one can really multiply to get anything we want, and we want to get it into cosine. So how can we make the denominator of the left side a cosine? Well, it's already at 1. So if we multiply that 1 by just cosine, we're going to get cosine as our denominator. So the top's going to be sine x cos x, and our new denominator is going to be cosine x. And you might notice that if we cross out factors we see on the top and the bottom, right, cos x, we're just left with sine x, which is what we already had, except now our denominators are the same. So we can add those fractions together. And on the bottom, both denominators are already sine x. So that's going to be a little bit helpful, right? When we're adding those fractions, they're already common denominators. So let's just go ahead and add these together. Okay, so on the top here, this section, that's just going to be the numerators added together, sine x cos x plus sine x, right? We're just summing together what we see on the top. And that's going to be divided by our denominator, which was cosine x. Okay, and we're dividing all of that by what we see on the bottom. So both denominators here are sine x. We're going to keep that the same, so it's going to be over sine x. And the top is just kind of summing everything we see on the top together. So it's going to be cos x plus 1. Okay, so lots of fractions here, lots of trying to simplify and factor things, but now all we have to do is, like we did on the right side in the last question, okay, whenever we're dividing by a fraction, we can multiply by the reciprocal of the bottom. Okay, so actually first what I'm going to do is, I see on the top that we can factor out a sine x, right? Because both terms, sine x cos x and sine x, have that common factor, sine x. So if I factor out a sine x, that's going to be cos x plus 1, kind of on the inside of those brackets there. Okay, so what I'm going to do now is I'm going to write what we have on the top, right, our numerator, sine x cos x plus 1, that's what we just did, right, divided by our lowest common denominator of cosine x. Okay, and instead of dividing by this denominator, I'm going to multiply by the reciprocal. So the reciprocal of cos x plus 1 over sine x is just sine x over cos x plus 1. We're just flipping the top and the bottom. Okay. So what you might see now is that we have a cos x plus 1 on the top and a cos x plus 1 on the bottom. And since everything in here is multiplying, right, the cos x plus 1 is multiplying into that sine x, and the cos x plus 1 is multiplying into the cos x on the bottom, we can cross out what we see on the top and the bottom. Okay, so those cos x plus 1's just disappear, and what we're left with is sine x over cos x times sine x divided by 1. Okay, and when we multiply tops and tops, and then bottoms to bottoms, right, multiplying fractions, we get sine squared x over cos x. And when you look at that, that is exactly what we got up here. So left side equals the right side. We have just proven these expressions to be equal. Okay, so now I'm going to try and think of another one that we can do here. Let's do one over, I'm going to move this over. 1 over secant x minus tan x minus the fraction secant x plus tan x. Okay, I'm going to say that that is equal to 2 tan x, and we're going to try and prove this. Okay, so like we do in every single question with these proofs, we're going to try and focus on the harder side first. So I would say that this is the harder side, and we're gonna get secant and tan in terms of cosine and sine. Okay, so it's gonna be 1 divided by 1 over cos x, right, minus sine x over cos x, and we're subtracting that fraction 1 over. Same thing, except instead of a difference now it's a sum. So 1 over cos x plus sine x over cos x. So the good thing about this question is that the denominators are already common. They're already cosine. So we don't have to do anything funky here. All we do is we're going to have 1 divided by, the denominator is going to be cosine x, right? And then we're just seeing what we have on the top and the bottom, and we're just kind of adding it together. Okay, same with this side. It's going to be 1 plus sine x over cos x. Okay. So what can we do from here now? Well, we know that instead of instead of dividing two fractions by a fraction, we can multiply by the reciprocal. So 1 over 1 minus sine x over cos x, that's just going to be 1 times cos x over 1 minus sine x. Okay, and then we're going to do the same thing over here. We're going to flip the top and the bottom. It's going to be cos x over 1 plus sine x. Okay, so now these factors on the bottom, or these denominators, aren't common, so we're going to have to make them common by multiplying by what's called the conjugate. So anytime you have 1 minus something on the bottom or 1 plus something on the bottom, okay, you're going to multiply by what's called the conjugate. The conjugate of 1 plus sine x, that's just 1 minus sine x. So it's the exact same thing, just different signs. And then you're going to do that on the top and the bottom, right? Because we can't change the value of the overall function or expression. And I don't have room to write it on the left, but all we're really putting in there is we're going to multiply by 1 plus sine x over 1 plus sine x. Okay, so I don't really have room to write it, but you get the idea. So the top of the left is going to be the cos x we already had times that conjugate we multiplied by, right? And we're dividing by 1 minus sine x times 1 plus sine x. That's the difference of squares, just factored. So it's going to be the difference of the two squares, 1 minus sine squared x. Okay. And we're going to be subtracting cos x times, remember the conjugate of the right side was 1 minus sine x. Okay, divided by the same denominator, 1 minus sine squared x. Okay, so I'm kind of creeping onto the right side here, but that's okay. Now that the denominators are common, right, we can just write this as 1 minus sine squared x as kind of one giant fraction with that denominator, and then I'm going to distribute this cos x into everything here. So it's going to be cos x plus sine x cos x. Okay, and then we got minus cos x. And then we're subtracting cos x times sine x, so that's going to be plus sine x cos x. Okay, and combining like terms, I see that cos x minus cos x is 0. Okay, so those are going to cancel out. And I see that we have a sine x cos x plus another sine x cos x. So this is going to be 2 sine x cos x on the top, divided by 1 minus sine squared, but 1 minus sine squared is also cosine squared. That's another Pythagorean identity that we're often going to be able to use. Okay, now what I see here is that we have everything multiplying into itself on the top and the bottom. We have 1 cosine on the top, and we have 2 cosines multiplying on the bottom because it's squared. So if we see something on the top and the bottom, we can just cancel it out. So I'm going to cancel out 1 cosine on the top, 1 cosine on the bottom. So it's just 2 sine x divided by cos x. And sine x over cos x is just tan. So this is 2 tangent of x. And I think we have just proven the identity. Yes, we have. So without even doing any work on the right side, we've proven that 2 tan x is equal to the expression we started with, because we have the left side equaling the right side. That means we're all good. So this is kind of some different types of questions that you'll get with trigonometric proofs. They're all kind of the same thing. Left side, right side, trying to prove that both sides are equal using the identities that you know and kind of your skills with algebra. So they can get pretty involved, right? Multiplying the top and bottom by conjugates, right? What's that all about? But you'll find that when you do that, you're going to get some identities that show up that are going to be easy to kind of substitute in there and make things a lot easier. So I hope this video kind of helped with your struggles or your interest in trigonometric proofs. And yeah, I'll see you in my next video. Thanks for watching.